we shall take this fourth example. If f is a function from R to R, f is a function from R to R defined by f of x equal to 3 minus x cube whole raised to 1 by 3, then find f composite f of x. I take f composite f of x, and one thing you remember, when we take a composite function, so always remember that this O is replaced by flower, means it is f of x. So, you see here O which is replaced by a flower, remove that O and put the flower bracket, and this is f of, I put the value of f of x, which is here 3 minus x cube raised to 1 by 3, and for the sake of convenience you can take this as f of y, where since y is 3 minus x cube raised to 1 by 3. Now, f of y means put here x equal to y, so you will get 3 y cube raised to 1 by 3. So, this is equal to, I put the value of y 3 minus, see here y is this one, I write this as y, which is 3 minus x cube raised to 1 by 3, and this is y, cube means we raised to 3, and this bracket raised to 1 by 3. So, this 3 and this 3 get cancelled. So, we have, see here what is left, 3 minus x cube after cancellation of this 3 raised to 1 by 3. Now, this is, see here 3, I multiply this by minus sign. So, minus 3 minus x cube raised to 1 by 3, plus 3 minus 3 get cancelled, and x cube raised to 1 by 3, and this 3 get cancelled, we get x, and that is nothing but a identity function, IR, identity function in the set of real numbers. Now, after that next example, so fifth one, find G composite f and f composite G. Find G composite f and f composite G if number 1, f of x is mod x and g of x is g of x is mod of 5x minus 2, and second one is f of x equal to 8x cube, f of x equal to 8x cube, and g of x is x raised to 1 by 3. f of x is 8x cube and g of x is x raised to 1 by 3. So, I take first example. So, first f composite G we shall find out. So, I write f composite G of x. So, f, remove this O and put the flower bracket, G of x. Now, I put the value of G of x, which is f of mod of 5x minus 2, and this equal to G of x is mod of 5x minus 2, and f of x is mod x, means it is mod of 5x minus 2, because your x is mod of 5x minus 2, means we can write this as mod of 5 minus 5x minus 2, which is your f composite g of x. And g composite f of x is g of f of x, remove that O and put the flower. Then this is g of f of x, means f of x is mod x, I write here mod x, and g of x is mod of 5x minus 2, but x is here mod x, means mod of 5 mod x minus 2. This is your g composite f of x. Now I take second one, f composite g of x, which is f of g of x. F of g of x, I put the value which is x raised to 1 by 3, x raised to 1 by 3, and f of x raised to 1 by 3 means f of x is 8x cube. So first I write 8, x cube means your x is here, see here x is raised to 1 by 3 means x raised to 1 by 3 cube. Look here, 8x cube, 8x is x raised to 1 by 3. This 3 get cancelled, we get 8x. This is the value of f composite g of x. G composite f of x, which is g of f of x, g of, I put the value of f of x which is 8x cube, and g of x is x raised to 1 by 3 means x raised to 1 by 3 means your x is 8x cube. So, 8x cube raised to 1 by 3. So, this I write as 2x whole cube, because 2 cube is 8 and x cube, this raised to 1 by 3, and this 3 get cancelled, we get 2x. So, this is the value of g composite f of x. So, f composite g is 8x and g composite f is 2x, and 8x is not equal to 2x. After that, the next example, sixth one, f is a function from R to R defined by f of x equal to 10x plus 7. Let f is a function from R to R defined by f of x equal to 10x plus 7, find the function g from R to R, find the function g from R to R such that g composite f equal to f composite g equal to identity function R, such that f composite g is equal to g composite f equal to IR. IR means it is a identity function in the set of real numbers, means I is x, where x belongs to R. So, first let us write here solution of this example. Given f composite g of x or g composite f of x is equal to I, means I take here g f composite g of x, which is identity function, means x. In the first year PUC you have studied what a identity function is. X is called as identity function, and this is f of g of x is equal to x. Remove this O and put the flower, and f of g of x means f of x is given 10x plus 7, but x is here, see that x is here, g of x means 10 g of x plus 7 is equal to x, and this implies 10 g of x is equal to x minus 7, and this implies g of x is x minus 7 divided by 10. This is your required function g of x. Now, after that eighth one, here given let f is a function from R to R be defined as f of x equal to 3x minus 2 and g is a function from R to R be defined by g of x equal to x plus 2 divided by 3, show that f composite g is equal to IR. IR means identity function in the set of real numbers R, x. So, let us take f composite g of x, solution of the example, f of g of x, I write f of g of x, the value which is given here, I put that one x plus 2 divided by 3, and this equal to f of x is 3x minus 2 means I write here 3, but see here x is, this is your x means I write as x plus 2 divided by 3 and this minus 2. Look here, f of x is 3x minus 2, 3x minus 2, your x is this x plus 2 divided by 3. This 3 get cancelled, it is x plus 2 minus 2 plus 2 minus 2 get cancelled and x, and this is your identity function R. So, identity function means remember x it is in R, and if it is in the codomain we get y. Now, after that ninth example is if f of x is root x, and here of course x is positive because root x is not defined for negative because we get imaginary number, and g of x is x square minus 1, find g composite f, find if g composite f is equal to f composite g. So, first I take left side g composite f of x, which is g of f of x, and g of f of x means I put the value which is root x, and g of root x, look here f of x is root x, I put here value of f of x root x. Now, g of x is x square minus 1 means your x is here root x, x square means it is root x square minus 1 means it is x minus 1. So, this is your 1. Now, I take f composite g of x, which is f of g of x, I put g of x value which is x square minus 1, and f of x square minus 1 means f of x is root x means root of x, but your x is here x square minus 1, and look here 1 and 2 implies x minus 1 is not equal to root of x square minus 1 because they are different. So, this implies G composite F is not equal to F composite G, which is your answer. Now, after that, 10th example. F is a function from R to R, be a signum function defined by, you know that a signum function F is a function from R to R, be the signum function be the signum function defined as f of x equal to, I have studied that in the first equation, and in the previous part I told that one, its value is 1 if x is positive, 1 if x is positive, 0 if x is equal to 0, and minus 1 if x is negative. And G is a function from R to R, G is a function from R to R, be the greatest integer function, be the greatest integer function, defined or given by g of x equal to square bracket x, where square bracket x I will not write that one, integer less than or equal to x, then does f composite G and G composite F coincide in, does F composite G and G composite F coincide in semi open closed interval 0 1, coincide in 0 1. Let us take first f composite g of x. So, first I write here f composite g of x, so which is, I write that as f of g of x, and f of g of x means this is f of square bracket x, because greatest integer function, and given interval is 0 1. So, I write its two value we have. I write is first it is f of 0 for 0 less than x less than 1, means for all values between 0 and 1 interval, means if you take any value between 0 and 1, you know the greatest integer function. So, here greatest integer function, this is 0 and here it is 1, next it is 0 and here it is 1. So, any value between 0 and 1, it is always 0. So, I have taken 0, and next when we have equal to 1, because here 1 is included, when we have equal to 1 means when we have 1 means g of 1 is 1 means it is 1 for x equal to 1, Now, this equal to See here, f of 0 for 0 less than x less than 1 means it is a number greater than 0, and for x greater than 0 its value is 1. I write here for x greater than 0 I write. Here you can also write x greater than 0 but less than 1, and f of 1 means this also value which is greater than 1 means it is also 1, means we can say that f composite g of x is equal to 1 for all x belongs to 0 1, x belongs to 0 1. Now I take after that G composite. So here what we have taken, f composite G. Now I take G composite f. G composite f of x, which is g of f of x, g of f of x. Now I divide the interval 0 to 1 we have given. So first I take signum function greater than 0, I take. When x is greater than 0 means, see here, when x is greater than, look here, interval is 0 1 means left side we do not have any value and 0 is not included because here it is open, but 1 is included here. So this is the interval of positive number which are greater than 0 means we take here 1. So g of 1 I write. This is for all x, what is that, greater than 0, and this equal to g of 1. G of 1 means it is square bracket 1, which is 1 here, which is 1. Next I take so what we got here, zero 1 so when x is f of 0, here f composite g of x, f of g of x, which is f of square bracket x, and f of square bracket x means I take value 0 less than x less than 1 means which is greater than 0. So we have any value between 0 and 1 means it is 0. So f of 0 sorry, here f of 0 means here we get a 0. I am sorry, here f of 0 means, so f of 0 we got, and when we have 0 means the value of f of x, f of 0 is 0, and x is equal to 1 means here it is 1. So we get here two values, f composite g of x, I am sorry, which is here, and this is for x equal to 1, x equal to 1. Now, so here for x greater than 0 means this is for all x belongs to 0 1, where 1 is not included, means observe here, this is your 2 and this is your 1, but when x greater than 0 means, see here, this is the interval same as 0 1 and this is same as 0 1. Here we are getting 1 and here we are getting 0, means I write here, since f composite g of x is 0 and g composite f of x is 1 for all x belongs to 0 1, and this implies f composite g of x is not equal to g composite f of x, means they do not coincide. So they do not coincide, they do not coincide in interval 0 1. That is the solution. So, next is after that 11th example. F and G are two. Let f, g are two functions from both R to R defined by be two functions defined by f of x equal to mod x plus x and g of x is equal to mod x minus x for all x belongs to R. Then find f composite g and g composite f. So, first let us define the two given function. So, first I write here given f of x, which is mod x plus x for all x belongs to R. So, this I can write as, see here I divide this real number set of real number, negative real number and positive real number. Negative real means mod x value is minus x plus x for all x less than 0 and x plus x, because mod x value is plus x for x positive means it is x for all x greater than equal to 0. Means this implies I write that as f of x equal to, so it is 0 because plus x minus x cancels, for all x negative less than 0 and it is 2x for x greater than equal to 0. Now, I take next function g of x, see here, which is given as mod x minus x for all x belongs to R. So, here also divide into two, one is positive real number, another is negative real number. So, negative means it is minus x for x less than 0 and it is plus x minus x for all x greater than equal to 0. So, this get cancelled. So, this implies g of x is it is minus 2x for x less than 0 and it is 0 because plus x minus x cancels for x greater than equal to 0. Now, let us find out f composite g and g composite f. So, first I take f composite g. F composite g of x, which is f of g of x, and this is I write here f of, I write this f of it, I put the value of g of x, see here, which is minus 2x for x less than 0 and I write here f g of x value is 0 for x greater than equal to 0 and this equal to, see here, f of 2x, f of minus 2x when x is negative. When x is negative, the value of function is always 0 for all negative values, means here we get 0. So, here for x less than 0 f of minus 2x and for x f of x value is always 0 for x negative x less than 0. For x less than 0 I write here 0 and for x greater than equal to 0 the value of the function is 2x, value of the function is 2x and here we have 2 into x, and when we have 0 it is 0. So, I write here for x less than 0 and for x greater than equal to 0. And next I take z composite f of x, which is z of f of x, and I write here g of f of x, f of x, g of f of x. F of x is given 0 it is. For x 0 means I write here 0 for x less than 0, and next I write here g f of x, its value is 2x for x greater than 0. So, I write here 2x for x greater than equal to 0, and this is, see, g of 0, g of 0, g of 0 means, see here x is 0 means it is 0, and g of 2x for x greater than equal to 0, which is 0 here. So, look here for f of 0, f of 0 means we should put here x equal 0, because it is f of 0 means here we get 0, I am sorry. So, here this is for x 0 and this is for x greater than equal to 0 means here we have 0 and this is also 0, means we can say that f composite g of x is equal to g composite f of x, which is 0. So, little difficult examples they are. So, if you do not understand, we shall discuss that further once again, no problem. After that, next this example, which is 12th example, f and g are both function from R to R, which are defined by f of x equal to mod x and g of x equal to greatest integer function square bracket x. Then find f composite g of 5 by 2 and g composite f of minus root 2, and this is from CBSE 2010, and once it is appeared in the examination March 2016 examination. Look here, first I take f composite g of 5 by 2, which is f of g of 5 by 2, and this is f of square bracket 5 by 2, and you know that f of 5 by 2 means it is square bracket, I write here bracket 2.5, square bracket 2.5, f of square bracket 2.5, and 2.5 means this is left side 2 and here it is 3. 2.5 means the value of the greatest integer function is always equal to how much it is? 2, left side. Immediately the integer which comes in the left side means it is nothing but it is 2, and if the any value between 1 and 2 it is 1, 0 and 1 is 1, minus 1 and 0 it is minus 1, etc. Next g composite f of minus root 2, and this is g of f of minus root 2, and this is g of because this is 2, sorry, f of 2 it is, and mod of 2 is nothing but it is 2, because f of x is what is that, mod x, and mod of 2 it is 2. G of f of minus root 2 means mod of minus root 2, and this is nothing but g of root 2, because mod of minus root 2 is root 2, and root 2 means this is value 1 and here it is 2, and root 2 means it comes in between 1 and 2 means its value is I write the square bracket root 2 means it is nothing but it is 1. So, 2 and 1 are the required values. After that, these two examples we shall discuss in the next session. Okay, my dear friend, thank you.